we move to the second part of this fractal drawing. It's called Barnsley Fern. So Barnsley is her name. In Chinese, it's 巴恩斯利. And Fern is this kind of the plant. This type of the plant has trees. Or not a tree, it has a quite long history in Earth. So, but you can see the pattern is this shape. If you put that as this edge, it's quite same as every leaf, and every leaf also have the subleaf, and they can just keep reading. The divided further. So that is our very typical fractal, the shape that we can discuss. So within this program, we will do this Barnsley Fern drawing. So, but before going that is, let's recap. Is in the last video we do the transformation of a point in our plant. How we did that when we do this kind of the moving, so moving from up and down, and axis in Y, and in axis just keep moving to the right. And then that is our ways we have a 3-step. You remember, first you need our origin point, or the initialization of the shape and the position. Secondly, you need to identify how many times you will use to repeat. That is those you can set by the inputs is from smaller to the larger. And the third part is you need to make this transformation rule. So once you define these 3, then you can start to draw those fractal drawings. So we did this, and when we run this, and let's see. So when I run that, and I gave our 10,000, then I got this drawing. But what if is I put this X also can be this. Let's make our the variation of this. So let me see here. I have the enhanced. So if I make 2 more, so let's see. So here, so I copy this like R3 and 4. So this you can see is X, Y. They have 4 different combinations. Here is 1 and 2 are just the axis keep plus. Then let's see if X can also randomly can move to the left. What that means? So the very easy is we can just put here. So not too many change. So here is 3. Here is 4. So is enhanced to all of 4 directions. You can keep adding more. So, but if I just save this, so now we have 4 transformation rules. Let's give 100. So you can see here is starting from 0, 0. So it's here. Then it can be run here at this direction, or this direction, that direction. So it's getting our to all the directions. So if I make that bigger, so let me see. I gave that's 100,000. So you can see that is also give another type of the pattern. So that will show you is if you have some different transformation rules applied to the same program, you also can get the different the results. So if I want to just see here, so you can see, so it's getting the more and more the clear. So if I put in here, so it's just all kinds of the possibilities can be having using this way. So that is our simple expand. Now let's go to this one. So let's starting to see is what are the rules for this Fern-like structure. So this is the plant as I showed in the PowerPoint already. So also starting from point 0. So that means is now is we. Oh, if I put this 0, so let's see. So I put this starting from 1. So maybe let's. Then that can be the kind of the balance. So these are, you can see like this shape. If I run this another, it can be the different shape. So that is depending on, but 0, 0 is here. So they can come into from here, then gradually is go to some directions. So you are not able to foresee where it coming. It's depending on the random. So that is the this part. And for making this the Barnsley form is the similar like our enhanced this zigzag path is there's 4 different rules, but the rule now is getting a little more complicated. So the next x has a certain these functions to both x and y. The next y also have the function to the here is a function only to y. So that is the, if here is the y, I think it is not correct. So you can see here. So transformation 2 is 0, 3, 2, 3 to 2. So this book here has some this arrow. So here should be xn, and the first this coefficient, this this variable should be x. So every and this transformation 3, the 0.28 is y. So let's ensure is you will use the correct rule. So every next variable will based on the first is x, the second is y. So that means is they are mixing x and y to define next x and the next y. So we have the 4 rules. That is the we already through this zigzag expansion you already have ways to see no matter how many rules, as long as you have the random selection or random choice, you just treat them as one of the list of the rule. The second difference compared to zigzag is they within this Fern-like structure, the random this selection, the probability is not uniform. So now is we remember after uniform distribution, we also learned is non-uniform. So now this is the non-uniform probability distribution. So the first rule have the largest probability to be occurred is 85%. Second and third row both has the either of these 2 and 3 has a 7% probability, and the last rule only have 1%. So they are not balanced, not uniform. So these are the two the difference. But besides that, we don't have the other difference. Just we applied different the rules for here. So you can see here is convert from this zigzag to this Barnsley form is not a big issue, difficult. So we're starting from this enhanced because we create 4 rules already. So let's make this 3, and then we have our Barnsley form. And we put this bigger. And we have the random. Let's see what we will change. We have this mat. Now let's starting to make our transformation. We already construct the 4, so just let's ensure so we key in this correctly. So we use this return p, so we just continue to do that. So replace x plus 1 is 0.85 times x minus plus 0.04 y times y, and the y is negative 0.04 times x plus 0.085 times y plus 1.6. So let's verify here. So correct. Then second one, let's starting to base on this minus 0.26 and 0. So keep in mind is here some this printing error. But if you here it should be x plus 0.22 y plus 1.6, and our rule 3 is negative 0.15, 0.28 y, and 0.26 x plus 0.24 y plus 0.44. The rule 4 is quite easy. So it's just x keep 0. So that means if go to the rule 4, it will back to the origin x. So let's verify with our code here. So this one, correct. This one, correct. This one, correct. This one, correct. This correct, this correct. So before we move on, so we have this zigzag base. So let's see what this randomly gave us. So just 1,000. So you can see here they already making something is expanded, but it's not like nice because we are not adding those. We just keep those. So maybe let me give some bigger. What that looks like is calculate. Oh, it's if I put some zooming, it's not recognizable. So let's ensure so we have our rules already. So let's back to here. So for the font, so first is p. We don't have this p. I think is we start with 0. So x is 0. So this one is still same. So we don't need to change that. So it's just starting from this x 0, 0. So we can leave that. And n is enter the number of points. Let's see. Change this message in the for. And then we use this build. So this build is we change the name. So draw for. And then we change this to here. Then this function will be conform. And we send this draw form with just p and n. So we still send this p. So then we don't need to change our program. Then plot is we use this just use the those circle. So small o is the circle. And then the title, we give a title for with 0 points. So this format we now know is quite easy. So just n then show. So until now is we're still in the zigzag part. Let's examine here. Draw this one. So x1 y1 is 0, 0. And then we starting to have this transform. So P is the transform using this this part, then this and X append X1 P. Yeah. So all these are still same. So we have X XY. So but where we use XY. So we send this to here. So draw this XY. We send here. So X1 transform P. So that's still same. So draw this one. So this actually is not needed. So because we send this P to there. Then let's see what's the difference to the transform. Transform now we have this 4, so that we already have. And the difference is we have another list, so probability. Otherwise, is we are still in this zigzag. Probability is equal to 0.5, 0.07, so 0.07, so 0. This is the experience figure, so let's keep that. And then the pick our random transformation function and call. So what we will call is we need to get our probability, the function. So this probability means that we have 85% of the chance to call transformation 1. So we need to make sure so we have our way to get this 85 chance to work. So we send probability to our get index. So this transformation index is equal to get index using this probability. Then let's see how we can utilize those index, because here is the index is have our probability value. So this is the additional the functions we will have. So we starting to use here with the random, and here we don't need random anymore. So let's say here is we have random. So if we use that, you get our the floating number within 0 and 1, and we put this C probability as the initial 0, and sum probability is empty list. So here we need to understand carefully. So what's the method or approach is the user use, author use. For P is the probability in the probability. So we transfer a list. So that means this range is for those probability number. So for every the probability number is we put is C plus C underscore probability equal to C underscore probability plus P. So we can use this P. But what's the P? P is the 1 by 1. So first P is this one. Second P is this one. So and then this let's see if where we use R. So R is our random number, and we make that, and we put this sum probability dot append C probability. So then from here is we put our just accumulate summary. So first is the 0.85. Second is the 0.85 plus 0.037. So that is the 0.9 is a 92. And the third item in the new list, the sum probability will be the 0.99, and the last it will be the this 1. So let's make a print sum probability. And then we know that is what that means. So we can see it's 4 item, SP in enumerated the way. So in the sum, so sum has these four accumulated those summary results. So if we want to see items and SP, so if item means we get this index number, SP is this value. So R you see is our random is within 0 and 1. So we compare R with this SP. So if R is no more than SP, then we return item. So what that means? If R is if R is SP is 1, maybe its SP is let's see. So the numeric is the first one is 0.85. If R is no more than 0.85, we can see that is in this 0.85 the way. So let's see. So maybe I can use our PowerPoint to make our picture to draw. So we have 4 possibilities. So first is this one, and then this we can see here. I see. So we just make this close, and then last one is, so this is the 0.85, and this is the 0.07, and this is 0.07. So this one is just 1%, we know. And our accumulate the list. What's that list is first the sum probability is 0.85 and 0.92, 0.99, and 1.00. So if our R is random, is below, is within 0 to 1. So if R is if R equal to 0.7, then we can see we will get this SP item is the first item. So index return will be 1. If I is happen is 0.93, so it's below this one. Then this we have the random is if that's is more than this one, below this one. So then this our index will be the third one. So actually index is 2. So that is the way. So we try to make our random within this range, and we find the this non-uniform way to pick up is which is our index, because we compare with the value, then we get index. When we use the enumerate way to traverse our list, you have the two these values you can use. So with that, then if we can return this item is what we are going to do. The the index. Then what we will return. So the return is a T index. T index is the, let's see, the length of probability. Length is the probability is 4. So 4 is then is we will make that is to -1. So then this will be our index get that. So then we have this T index returned. And then we will use this T index to transform. So we don't need this random now. So we just now can call this transform. So we also need our transformation. So here, transformation is here. So we already have our defined the index. Then we use this T index. So then I will keep this P. We send our tuple, so we get a tuple. So now let's, I think it's that's all. transformation, and we already have these four the rules. So let's just make her 100. So transformation t index list item is not our callable. So t index, so t index transformation. Oh yeah, so sorry, here should not be the parentheses, it's a list. So we should use this index way to get that. So let's see. So this is the 1000. Let me go to just 100. It's already have some the similar way. So I put this one. So you can see here print. I print this probability. So because we run all the times, so this one, so we can comment that. But this conform is 0.85929910. So now let's go to 1000. Oh, it's not correct because it looks like it's only in the left part. Let's go to this 1000, 10,000 to see. We may have some errors. Oh, it's only in here, but looks like it's 100 has both. Oh no, so I don't have that both. So why they only go to the left part? So let's have a look. So it's not defined here. So draw this and X, and we have our transform X, Y. So that's fine. Append this, and return X, Y. So X, Y is this one. So P, so transform. And then let's see here. This one, T index transform. I suppose that should be our rules. I have some issues. This is we redraw. So here 0.616 and 0. So that's no problem. Minus here. So is this the rule 3? But here is the minus, but here is the positive or addition. So let's see whether it's this one. So let's 10,000. Oh, correct. So let's trust the actual program here. This one also have our wrong typing, I think. So, but we can check from here. So this you can see is actually the transformation. So if we do this one, it's like 0.85 times x, this times this, and this times this. So 0.04. So I think it's yeah. Let's verify. So this one and minus this one and 0.2. Mine is minus 0.6. 23 to 2. Oh yeah, here it's actually this is correct. It should be the positive 0.28, and here is both positive. So so I think it's yeah, it's better. Let me put this also here, reference link. So that you can also get this directly for the one. So let's make a larger one to see. So maybe I gave this. You can see now it looks good enough if I putting that in the biggest one. But we just use the dot. So if we maybe let me change to our hyphen. Let me see. Yeah, so that is not looks nice. So dot is the or maybe I put this star. Star is looks better than I think is by just a dot. It's more look like our this more natural based these leaves. So that is the standard transformation rules for to making this fern. And actually, is if you adjust these coefficient values, I believe you can get the different type of the leaf. But that is not the purpose for our this coding. So as a recap, so if you want to do our this fractal drawing, so actually let's remember the three key steps. First, you need to have our the initial the point. Here is our initial point, change from 1, 1 to 0, 0. Secondly is decide how many times or how many iterations you will repeat, because the fractal is the repeating the simple shape to form our complicated shape. And the third is the differentiation for compared to the different fractal is your transformation rule. And the rule can be complex, can like this, or can be simpler like the earlier one. And for this foreign type, the structure, we also add our number 4, the factors, but it's not mandatory. It's the non-uniform the distribution or non-uniform probability. So if you have that, you can get something is not in the balanced way. So if I change this to another the probability combination, you will get another type of the leaf or the form. So try to practice yourself on this fractal, and I hope you can enjoy the result. And this is kind of the surprising is how easily we can use no more than 100 lines. We can build so complex the drawings or diagrams. If you put that in the I think you can add more colorful ways. You can send the color and you can randomly pick up the color. Then that will be our rainbow based or the colorful this foreign leaf. So try yourself to enhance this code. But for our this learning on the book is in this chapter we already finished this 2 subchapter. We starting learn how to draw basic geometry shapes and how to animate that. The process introduce you a numbers of the new features like that patch. And then we learn this geometry transformation and see how repetitive simple transformation have to draw the complex geometry shape. We call this fractal. So from next video is we will again move to those the challenge. We have 4 challenge. First is just packing circle into our square. It's just use the way we learned from the 6.1. And then these 3 is we can draw some complex shape using the fractal the rules we learned. I also put this Chinese translation here, so hopefully you can also get run those reference beforehand. When I finish this, as usual, I will link the code here, and I will gradually to add some the reference link in the Wikipedia to this mind map so that you can take a reference. And then this try to practice and ensure you have our correct this Barnsley foreign code on hand. We use those as base for some of the additional this fractal code later on. So see you in the next video. Bye for now.